Hey guys, this is Aaron Roof at Vanteon. I'm the Chief Technology Officer here, and I just wanted to take a little bit to kind of unbox our new software-defined radio platform that we call vNassa. So here's a quick look at vNassa. It's based on the Analog Devices ADR-V 9002, which is a brand new part that Analog Devices just released. That is their first wideband transceiver that's really designed for narrowband applications. So it can cover narrowband as well as some still wideband applications like LTE and so forth. So in addition to the ADR-V 9002, we also have on board here a Xilinx Zinc 7020. It has a dual ARM core plus pretty substantial amount of FPGA fabric to allow us to handle all different kinds of waveforms and signal processing, in addition to supporting Linux platform for Ethernet stacks, USB interfaces, that type of thing. And as you can see on the right here, we do support Ethernet. We have an Ethernet and a USB interface for high throughput applications. We also have a number of different kinds of serial interfaces like SPI and UART. We've got GPIO as well. The Zinc itself has interfaces to Flash and DDR for onboard applications for the ARM core. On the RF side, although the 9002 has a lot of wideband capabilities and wide frequency range, we have chosen to, for this instantiation, to include an RF front end that's specifically tuned to the 915 ISM band. So this allows us to target applications in markets that are industrial or medical type of applications where they want to use unlicensed bands, and we can get full 1 watt power allowed by the FCC for those applications with that RF front end. So it gives us some really good flexibility to target some real long range applications in the ISM band. As you can see from the picture, very small form factor. The overall dimensions of this are less than 3 inches by 1.5 inches. So you can see we're packing a lot of horsepower in a pretty small package. The key features of vNassa, so the core itself can handle 30 megahertz to 6 gigahertz frequency range, although as I mentioned, front end is currently tuned for a 915 ISM band, which only has 26 megahertz of bandwidth. The chip itself, though, can handle bandwidths between 12 kilohertz and 40 megahertz. Within the current front-end application space, we can only do up to 26 megahertz, but that's not limited by the part. That's limited by the ISM band itself. So the core, again, can do 2 transmit by 2 receive, although the front end is a 1T, 1R instantiation of that, and it's designed for time duplex mode within the ISM band. So although this is tuned for that 900 megahertz ISM band, we can very easily make a front end change, which allows us to take advantage of the full wideband 30 megahertz to 6 gigahertz frequency range, as well as the 2T and 2R capabilities. As I mentioned, instantaneous bandwidths go down to 12 kilohertz. So this is the first time in a wideband transceiver from ADI that they're supporting bandwidths as low as 12 kilohertz. As I mentioned earlier, the maximum output power for this instance of the radio is up to 1 watt because of that 900 megahertz front end that we put on there. So really good long range performance, given that we can transmit the full power allowed by the FCC. Also gives us a good noise figure on the receive. We get down below 3 dB noise figure, and that's with the front end and the filtering. We have support for spatial diversity through the front end as well. Even though we do only 1T, 1R, we do have antenna switch diversity capability, and there are 2 ports on the radio that give us that capability. The core itself has support for digital pre-distortion, which we have placed some hardware on the front end to be able to support that. Additionally, the 9002 has a fast frequency hopping mode, which is a new feature supported only on the 9002, unlike other ADI wideband transceiver radios, and we provide that additional support as well. So here, just to give you some quick application examples that we could utilize using vNassa, applications like automatic meter reading or advanced metering infrastructure, or things like smart grid or water meter reading. Also oil and gas applications like drilling or refineries, really good for that application because of the fast frequency hopping support in the 900 megahertz band front end that we have. Security systems is another good one because this radio can, in an instantaneous bandwidth, support wide bandwidths. We can do not only security applications for switches, but also for, say, video monitoring applications. Also, things like asset tracking and medical applications and transportation are good fits for this radio. Primarily, you would think of this as a collector system and a point-to-multipoint network, although security applications for video transmission may be like a point-to-point link. So if you have any questions on the vNassa application, we do have a landing page on the Vanteon.com website. Just type Vanteon.com/vNassa, and you will hit our landing page for our vNassa radio. Thank you very much.
vNassa is the latest software-defined radio platform from Vanteon Wireless Solutions. vNassa is based on Analog Devices' ADRV9002 highly integrated wideband RF transceiver and the Xilinx Zynq 7020 all-programmable system on chip. The ADRV9002 is coupled with a custom-designed, performance-enhancing 915 MHz RF front end, which provides 1 watt of transmit power. Together, these components create a flexible, cost-effective, and highly integrated SDR platform that balances performance and cost, and is perfectly suited for the narrowband industrial market. On the underside of the vNassa SDR, a high-density connector provides connections for USB, Ethernet, SD card, serial, and JTAG. For this demonstration, we have the vNassa board mounted on its companion development board. Along with the vNassa, there is a spectrum analyzer and signal generator connected to help illustrate transmit and receive functions. Looking at the vNassa board itself, we have 3 signals connected: an external reference clock, a spectrum analyzer connected to antenna 1, and finally a signal generator connected to antenna 2. With this equipment, we are now able to show some of the capabilities of the vNassa SDR. Switching over to the actual demonstration, on the right you see Vanteon's demonstration program for the vNassa board. On the left is the spectrum analyzer output to view the transmit signal. With this setup, I'm able to show some capabilities of our vNassa board. The menu on the right shows the transmit and receive carrier frequencies, along with the channel state. For the receive, the menu also shows the RSSI, which is disabled when the receive channel is not enabled. The menu allows toggling the transmit state, enabling transmitting of the test waveform. Currently, the waveforms include single tone and dual tone for testing. As a demonstration, we also have a YSUN-like OFDM test signal. Let me adjust the spectrum analyzer to view the whole signal. Going back to the main menu, let's turn off transmit and look at the receive. Enabling the receive enables the RSSI output, and you can see that there is currently no receive signal. Switching to the signal generator and enabling its RF output, you can see the corresponding increase in the RSSI output level. Our current FPGA design does not include any baseband processing, so the receive data is terminated in ILA within the FPGA. Using Xilinx's Vivado, we can inspect the receive data. By triggering a new capture, the receive signal can be seen. This concludes Vanteon's quick demonstration of the new vNassa software-defined radio. vNassa is Vanteon's SDR platform that is optimized for narrowband industrial applications. Contact us to learn more about how it can be used in your application, or, if needed, customized for your specific IoT application. Have a different SDR application you need to solve? Visit Vanteon's website to see our full portfolio of SDR platforms, or contact sales@vanteon.com for more information. From low cost to high performance, Vanteon has an SDR platform that will be the foundation for your next wireless solution.